Looks like you guys get to give somebody a hard time. Do it. Oh. Early is on time, my friend. Do this? I'm joking around, but it's all right. It's always great when it becomes a need instead of a want. Yes, definitely. Good morning.
Morning.
Good morning. 4 of you. So today, I'm going to show you a dictionary. This is a really neat way of organizing information. One of the things that I really like to explore is what the best way of storing information is for how we're going to use it. And so far we've really only dealt with a couple variable types, right? We dealt with storing a single value in a variable. Now that single value might be a string or an integer or a decimal number, things like that. We can put those in a variable, give it a name, and access it. Then we got a little fancier where we started using things like lists and arrays. And the way that those worked was we could put things more or less in an Excel spreadsheet, is what they look like in our conceptual mind. And you could access elements using things like the row and column that they're sitting in. Today we're going to talk about dictionaries, also known as hash maps, depending on the language you use. And what's neat about these is that they store information based on a thing called a key. That's how you find a piece of information, rather than just based on its positional index. So for example, a list does something like this, right? So I have a variable and I access it and I say I want item 1. We know that the languages we're using in this class all count from 0, so that's actually the second item in this list, right? So whatever's in there, my list of hard bracket 1 would get spit out like so. What a hash map lets you do is handle the situation of maybe I don't want to store things that way because now I have to always know somewhere else. If I want item 1, that's because I know it's already there almost. And so a dictionary or a hash map lets you reference entries in your list or your array by something called a key, which is usually a string. And so I can create an entry called Farrar, Tony and access it using this syntax, and it'll print out whatever's in my dictionary under that name. So places where this is useful are things like creating a user profile or storing experimental data, actually. And so I'm going to show you an example of how this works in Python. The concepts map to Swift and Java pretty much directly. Now, I bumped the font up before I plugged in. How'd it go this time? Back row. Sweet. Okay, so let's start here. This is a list that I have created. Oh, why does it do that? This is a list that I've created that has a few different entries. One of the interesting things about Python is that all the entries in a list don't actually have to be the same data type. So I've mixed some integers here with some strings. And I could print all the items in my list one by one if I type something like this, right? Print the name of that variable and then each of the indices. And so just to prove that this works, let me run it for you real quick. This will run, and there are all of the entries for you to take a look at. And that's great, but what if I wanted to print something like the quick brown fox and skip the others? I would have to know that the quick brown fox lives in slot 3. Not always the most convenient way of dealing with things. And so dictionaries are a way that we can handle this by sorting things by keys instead of by index entry. So I'm going to create a new variable here just to show you how this works. It's just dictionary. I can spell this array here. Okay, so then I could say item 2. What did I have there? 3. And then I could name it something completely different, say food. And the food is gravy. And the animal is the quick fox. Where have I messed up? There it is. Look at that. Single quote, double quote, snafu. And a comma there. And then we could say, I don't know, maybe order number. Order number. Maybe this is some really strange business. And a closing curly brace ends that. And so now when I run this code, I've created a thing called a dictionary, and instead of putting a value of 1 in slot 0, it's put a value of 1 in slot item 1. And so to access it, let me just type it in here for you. First, I'm going to just give myself a blank line so you can tell that this is a new thing. And then we could do something like print my dictionary. This will show you the whole thing all at once. Or we could print a single item, say my dictionary of item 1. Hard bracket there. And close there. And so now when I run this, what's going to happen is, first it prints out the whole dictionary where it shows the key value pairs. And then I said print item 1. Well, item 1 has in it a 1, so that's where this came from. And what's neat about this is, now I could say, well, all I want to know about really is the animal. Animal. So I use that key. And now when I run this, what do you think it's going to print? The quick fox. And so we run it, and out comes the quick fox. And so you could imagine lots of different ways that this might be useful. You want to print the animal and the order number, and now things, run them module one more time. And there you go, quick fox is order number 13. So, let's talk about this maybe in a little bit more concrete way. I'm going to give myself another blank line, and then I'm going to print, here comes some experimental data. Like so. All right, so I'm going to make a new dictionary, and this time I'm going to fill it with some experimental data. So I'm going to go out and conduct an experiment on an engine. I'm going to stick a probe in there and do some measurements of some flavor. And initially, one piece of information we're going to get from that are all the probe readings. That's the more obvious thing that we're going to get. But in addition to that, there's some metadata that we were interested in that goes along with this experiment. Maybe what day it was conducted, or what the atmospheric conditions were, things like that. And that's where these data types can come in really handy. So for example, I could create something like test date is March, what's today, the 4th, 2018. I could say that the atmospheric pressure was 14.7. I could say that the atmospheric temperature was, I don't know, 69 degrees Fahrenheit. Maybe there's some test condition that we're interested in, like the engine speed. That could be 16,000 RPM, perhaps. And lastly, we could have the actual raw data. Raw data And maybe this looks like a list of values like 1.1, 2.2, 6.8, 9.7. And so I conducted a trial and I collected this raw data. What's neat about this is that now I have all this metadata associated with this entry. And so I've created a little database that has more information to it. And so maybe I ran experiments on 6 different days. I could store all of them as different dictionaries like this. And then what gets crazy is that I could start creating dictionaries filled with dictionaries and have all of my experimental data in one place. Questions? Not yet? So how about we show you some things you can do with dictionaries. One of the neat things you can do with a dictionary is once it's been created, you can add elements. And so the way that works is that you type the dictionary, you type the new key that you want to create, and then what you want to stick in there. So maybe I want to do a little bit of math and calibrate my data. So I could have a new key that's calibrated data. I'm going to set that equal to, and to calibrate, maybe we multiplied this data by something. So now it becomes 3.3, 6.6, 47.2, or 3, whatever, and 87.1. So there I calibrated that data, and if I print my dictionary now, what will have happened is I will have created a new entry called calibrated data and crammed a new array into it. And so you'll see here that we've added one more entry to the array right there that's called calibrated data. So you can stick things in. Maybe these are users or something like that instead. Just like that, we can also delete an element using the del command, at least in Python here. And so, for example, maybe we want to get rid of the temperature, atmospheric temperature. That's just taking up space. For whatever reason, we want to remove that. If I print my array now, or my dictionary now, having deleted that item, you'll see that our last row here no longer has an entry for TATM, where here it does. So it deleted both the key and the value associated with that key. And one last neat little thing that you can do with it is you could sort your data by the keys. Maybe instead of having it print in this random order where we got test date and then we got PATM and then we've got engine speed, maybe we want to alphabetize it by key. This takes 2 steps. Okay, first let me just say what we're doing here. Sort by keys. And get myself a blank line just to make it easier for you to read. The first thing we want to do is we want to grab all the keys and sort them. So there's a really neat trick for this. So I'm going to create a new variable called key sorted. And I'm just going to grab all the original keys by doing dat.keys. That's the way of accessing the keys in a dictionary in Python. There's similar commands in Swift and Java. Now that's just going to grab them. So if I run this real quick just to show you what it's doing, print key sorted. If I run this right now, what you're going to get is just a list of all the keys. So that's nice, but we can go a step further if we use the function called sorted and drop that list in there. Now what's going to happen when I run this is it's going to reorder them alphabetically. So you see that originally our first key was test date, now our first key is calibrated data. And what's neat is now what I can do is build a new dictionary and build it in that order and grab my data along with it, and that'll let me have this thing sorted. So the easiest way to do that is just to create a new one and go key by key through, grab the data and stick it in. So for example, I could create a thing that says for key in key sorted. What's that going to do? Yeah. Right, it's going to go through the keys that are stored in key sorted, and one at a time, each loop iteration, the value key is going to take on one item from that list. But the neat thing is that it's doing it in order. So I could make a new variable called dat sorted of key and set it equal to the original thing of key, like so. And now if I print dat sorted, presumably what will happen here is I'll grab a key, I'll go to the old dictionary, use that key to get a value, and stick that in the new dictionary. But the thing that's interesting is instead of going in whatever order the original dictionary was defined, I'm going to go through it in the order of keys sorted, which are now already sorted. And so I'll run this. It'll throw us an error message. Because dat sorted is this new variable I've created inside of a loop here that's never been done before. And so intentionally did that one for you. The fix to something like that is to initialize it. So dat sorted, and we want to tell it that it's an empty dictionary, so I just give it some curly braces like so. And now when I run it, it won't throw an error message, and what you'll see is that I take the calibrated data, and there's the key value pair for that one, and then the next thing alphabetically is engine speed, and there's a key value pair for that one, and so on. And so I've taken the original dictionary and I've copied it into a new dictionary in order. Ask me questions. These things might be helpful on Friday. I'll be sure to post this code to Canvas. Did you know that I post all the code that I do in class on Canvas? Yeah? If you didn't, let me show you. Check this out. If I go to Canvas and I go to our thing, there is a tab here called Files. And if you click upon this thing and you go to the course notes, the first thing you'll see are all the lectures. These are PDFs of all the lectures uploaded for you to have access to. So whatever you've seen on the screen here is there. But then this code from class folder has folders for any of the days that had class in it. So for example, on Monday we did that symmetric matrix thing. Here is a beautifully commented version of what we wrote in class on Monday. There for your use. Oh man, this whole time? So, friendly reminder, where we should be at this point. You should be done with all of that stuff. We are in the process of evaluating eligibility. We are going to email you, but we will also email you if you aren't eligible so that you know one way or the other. But you can do this test for yourself. If you have over 70 on all that stuff, you're eligible. We might get down to the specifics of which date that happened, but otherwise, get to work. If you haven't finished these things, this is where you should be spending your time right now. Okay? And we are currently in phase 2 of the project. Monday was the cutoff for eligibility for that phase. Yeah? We're working on it. And it'll be based on your submission date, not how long it takes us to grade it. So don't worry there. We'll take care of you. The question there was, what if something hasn't been graded yet? We are working on that diligently. So one more time, just to remind you, phase 3's cutoff is coming up. We're going to the original schedule here this Friday. So if you're not done with this stuff, you really want to get there, because on Friday at midnight, we're going to be checking eligibility again. So zero in there so that you can join your company for next week's phase of the project. We are in full swing actually writing apps now. Just to remind you, this is what you turned in on Monday. I'm really excited because we got 25 submissions on time. There are 25 companies, so that's the appropriate number, in case you didn't know that. We are now working on coding up our core features. So last week's assignment, you identified one item as the most important thing. This week's job is to write the code itself that makes that most important thing work. And then we'll move into adding the GUI and the extra features and all the bells and whistles, final revisions, and a little demo. That's what's coming up. And so, to support you in this effort, once again, we would like you to submit one thing per group, one PDF file that shows your working code. Screenshots are the easiest way to do this. I suggest using something that shows your command line output so you can demonstrate that your code worked. Give me 3 more seconds and I'm going to turn you loose. What we want to do, really quick, is just teach you that the nicer you make it for us, the easier it is to give you meaningful feedback. Every computer has the capability of taking a screenshot natively. And then you can paste that screenshot into something like a Word editor, and then save that as a PDF, and you will create a PDF report for us to view. What you shouldn't be doing is taking your phone at some crazy angle, dimly lit, with snot and fingerprints all over your screen, and snapping a picture, and then somehow trying to turn that into a PDF. It's difficult. There's a button called Print Screen. If you have a Mac, there's not a button for it, but if you Google it, it'll show you the Apple Shift 3 command that makes it work. Questions on how to make a screenshot? Cool. Do that, paste them into Word, save as PDF, upload it. We've made it easy for you. The only thing that it'll let you upload is PDFs. What are you uploading? Well, this. This is your assignment due on Monday at midnight, and I'd now like to turn you loose and give you the rest of this class period to work with your company on achieving this thing right here. Any questions? All right, thanks everybody. Have a good morning.